She's like, I think it's going to be on by the time the hurricane hits. So it's pretty entertaining. All right, let's see. I'm going to share my screen. Good morning, everybody. Let's see. I'm going to go ahead and open attendance for everyone. Okay, so you can go ahead and do your attendance when you get a chance. I think. And then I think we were on Hawthorne, Haworth, Haworth Projections, and we hadn't done reducing sugars yet, correct? So we did this, did this. Here, the Haworth Projections, right? And we said they go from the straight chain to the ring, right? We did that. But I don't think we talked about reducing sugars.
No, we got really into like epimers
and structural things. I really can't believe that y'all didn't cover this in organic 1 or organic 2.
No. I think like nursing chemistry, they went through it.
Yeah, like I know I go through it in 109.
Yeah,
like
but not 10.
We did some like work and stuff like
In
that.
organic.
But we didn't know sugar.
You did no sugar. See, that's really good for me.
Like seeing it now, I have no idea what that was.
Okay. Well, that's good. It's okay. It's not what I was expecting, but that's okay. Because y'all rolled with it. Y'all got it. As we were going, y'all got it. So it's good. It's okay.
It's kind of like to explain to yourself, but it's not that hard.
Right. But it's not hard to understand. It's just if you've never taught it, you can't expect to know it, you know. So yeah, I get it. We got another 3 minutes. Is my watch that fast? Is it really 10:42? Yes. Okay, my watch says 10:44, which is probably good for me. Let's be honest. It's probably good for me. Okay, and don't forget attendance. I guess I should put that up so everybody can see. Don't forget to go ahead and please do your attendance. We got 23 responses. I'm hoping we got more than that. It's kind of chilly in here today. I kind of feel like I should have brought my jacket. My hands are frozen. What? Yeah, no, it's better than the ballroom. I teach 109 in the ballroom. Oh my God, it's freezing in there. It is freezing. I don't know if y'all have any classes, big classes like that. Probably not at this point. But I bring a jacket every day. One girl got dressed like she was dressed, but then she put on like sweatpants and a sweater during class. She's like, okay. I get it. All right, so y'all want to hear my bad joke for the day? Here you go. This is really the one I put on my son's lunch kit today. What do you get when you cross a kitty and a fish? Not a catfish, a piranha. I thought it was cute. Didn't see that one coming. Yep. The catfish was a slow pitch, but it wasn't it, right? All right. I know. I could bring a blanket. You know what I say? I tell my kids in my 109 class, I say, you need to bring a Snuggie. You know, they would laugh, but they go, that would actually work. Okay, so if you have not already, please go ahead and check in on attendance, and we can go ahead and get started. I think I want, see, it doesn't, anyway, okay. As I go back and forth. All right, so today we're gonna finish 6.2. We're gonna do 6.3. I already posted the videos for 6.4 and 6.5. They're short. They're short, okay? And I also posted long eye clicker questions. What did I say? We're gonna do 6.2 and 6.3 today. 9. I'm sorry, see, 9. We're gonna do 9.2 and 9.3 today. I posted the videos for 9.4 and 9.5, and those are the short ones. I also posted some long eye clicker questions that encompass basically the entire chapter. So it kind of integrates everything. There are only like 5 of them, just because we're taking a little more time on sugars than I thought we were going to, so we had to cut a little bit. So even if we go into Wednesday to finish up lecture, we can do that. All right, I also opened the self-checks for chapter 9 and chapter 10, which are going to be on the next exam, right? And I made them due at midnight the night before the next exam, okay? Then I also opened up chapter 11 self-check, but that one's not due until the Sunday night at midnight before exam week.
So chapter 11's not being added into the final?
It is on the final. Chapter 11 will be on the final, but it's not on exam 4. So we'll cover.
This is exam 4, 9, and 10.
Yes.
Okay.
Exam 4 is 9 and 10.
So we're not covering 12 at all.
We're not going to get there.
Okay.
It's photosynthesis. It's a plant. It's important, but you know, I'd rather cover what happens in us. You know. Okay. And that's all I have for announcements. So any questions before we rock back into sugars?
I just, if there's a question about like the Epimers.
Sure. Okay, so we have a question about the Epimers. Go ahead.
So with the penultimate carbon.
With the
Right. Is that the only one that is flipped for it to be L to D, like as in the
Correct.
Or is it the entire molecule?
Well, if you flip that one, you flip the entire molecule. So it's not necessarily that you're flipping something or not flipping something. If it's on the left, it's an L. If it's on the right, it's a D.
Right.
But now if you want to make the L epimer from the D epimer, then everything's a non-superimposable mirror image.
So is that the same thing with like the mannose, Zios, like the second and third carbon?
So this is a 1 carbon epimer when you compare glucose to mannose, right? They both have the hydroxyl on the right side, so they're both D. And if you check, everything else is the same except for carbon 2.
So like if you go to glucose and mannose, the glucose, the hydroxyl.
You go to glucose and mannose. Wait, go ahead.
Like the glucose is on the right, the hydroxyl glucose is on the right.
Uh-huh.
The mannose is on the left.
Y'all tell me the monitor's not on. And I'm gesturing on here. Everybody at home can see it. You need to understand epimers and enantiomers. You don't need to memorize what I would do. Glucose. I would know how to draw glucose. That is the one that I'm going to tell you to know how to draw. No glucose. Okay. So ask me again now that you can see and I'm gesturing and pointing. I'm sorry, I didn't have the projector on for the in-class people. So sorry. So if you have glucose and mannose, they both have hydroxyl on the right side. So they are both D. And if you look, it's not a perfect mirror image of one another. The only thing that's different between D-glucose and D-mannose is carbon 2.
So only that carbon flips?
Only this carbon flips between glucose and mannose.
Okay. So if the penultimate carbon flips, the entire molecule flips, but if it's like the second, third, fourth, only that carbon flips?
Correct.
Okay.
Correct. Correct. Okay. All right. So, yeah, we're all good on those. All right. So now you have your stick figure of your sugar, right? And your sugar is going to go into the cyclic form. Once we go into the cyclic form, you have to say what the orientation of the ring is. And the way that we do that is we look at the carbon that's sitting the carbon, come on. Oh, y'all. Why can't I draw? Oh, this is not gonna go well. See the little thing, and I'm on pencil. My God. I might have to shut down the computer and restart it. Oh my gosh. Okay. Well, I'm gonna go with this just for now, and I might have to restart. So when you're trying to decide how this cyclicization works, right? There are two different configurations that can happen. When you create a bond between, you left the timer on, FYI. Oh, it's fine. As long as everybody has time to check in. I'll turn it off in a minute. When you have this oxygen right here, this oxygen that is going to go in and create a bond with this carbon, so the carbon, that's the anomeric carbon, so the one in the double bond with the oxygen that I can't draw on right now, but the blue one. There are two different things that can happen. Either this CH2OH, right, is going to be on the same side or the opposite side of the ring as the hydroxyl that's attached to the anomeric carbon. What is the anomeric carbon? It's this one right here. I'm pointing to it on the ring. What do we call? It's called the anomeric carbon. Why is it the anomeric carbon? It's bound to two oxygens. So see how it's bound to the oxygen in the ring, and then it's also bound to an oxygen and an Na hydroxyl. This is the anomeric carbon. This is going to be really important when you're trying to figure out if a sugar is reducing or non-reducing. So do you see in this one where we have the hydroxyl on the anomeric carbon, it's below the ring, whereas the CH2OH is above the ring. So that's like a trans orientation, right? When you did organic, you did cis and trans, right? Did you do alpha and beta? Probably not, because you didn't do sugars. So in sugars, when you're looking at a ring, like if you took the ring and you set it on your desk, there are things that would be above the ring and there were things that would be below the ring. So in a two-dimensional drawing, everything that's pointing up is on top of the ring. Everything pointing down is on the bottom of the ring. And so the CH2OH is on the top of the ring. The OH is on the bottom of the ring. So this is a trans orientation, but it's a ring, so we don't call it trans, we call it alpha. So this is alpha D glucopyranose. So it's the ring form of glucose, okay? The other thing that could happen when this bond forms is that hydroxyl could end up on the same side of the ring as the CH2OH. So here, do you see how this one's up, this one's up? We're always going to basically assume that the CH2OH is in the up configuration, right? Because in 2 dimensions, in 3 dimensions, you can rotate the molecule any which way you want. So we're going to arbitrarily say the CH2OH is on the top. Now, how is that hydroxyl oriented? Is it also on the top? Then that's cis or beta in a ring form. If it's opposite, it's trans or what we call alpha in the ring. Okay? So y'all have heard of glycosidic linkages, right? Like alpha 1,4. So the alpha is telling you that you're in the trans orientation, and the 1,4 is telling you which carbons from the 2 rings are participating in the glycosidic bond. Yeah? So you've heard beta and alpha. You just maybe never had to like figure it out. Yeah, okay. All right. Okay, so when we look at these sugars, some sugars can be oxidized or reduced based on what kind of functional groups they have, right? So when we look, generally aldoses are reducing sugars. There are carbohydrates that can react with oxidizing agents. And I really want to draw right now. This is really hard. Okay. No, I really think I'm gonna shut down the computer and restart it, because that worked last time when this happened when I was teaching 109. So if you're on Zoom, stay on Zoom. But it's gonna shut it down. So do y'all understand? Do not go anywhere. I'm gonna shut it down, but I have to draw. I can't teach this and not draw. So do not go anywhere. I'm gonna shut down and then I'm gonna restart. So Zoom will be the first thing I open, but I've got to be able to draw. This is ridiculous. I can't do this. Let me see. Let me try one other thing before I shut down. If I do, like, this is so frustrating. What if I do it as a PDF instead of as the note file? I'm gonna try this, and if it doesn't work, I'm shutting down. Because I have to be able to draw. This is kind of ridiculous. Come on. Okay, I think we're having technical issues. So I'm gonna go ahead and shut down, and don't go anywhere. Okay, let me end.